Thank you. Thank you. So, hi everyone. My name is Giovanni Pepe, and I'm currently managing the corporate network and SRE team at Uber. And today I'm going to take you through the journey that we passed through for getting to Mist SD-WAN as a solution. So, let's look quickly at the agenda. So, first we're going to look a bit how our network changed over the years and in relation to the business need that we had to accommodate. And we are going to look at some of the SD-WAN advantages that are very simple case scenario, but I think it gave a good idea why we went with SD-WAN. Then we're going to look at our automation stack and observability and AI. Then we are going to just quickly touch base about what we're going to do with the HP solution in the future. And then last is basically my 2 cents on how the network landscape will change. So first and foremost, we go back to 2013. That's when the C round of funding of Uber arrived. That's what basically had the disruption of the market and our expansion, our tremendous expansion, which I would call hypergrowth. We started to be present in many countries, so we had to accommodate this expansion with the network. So what we decided at that point is just to build this very flexible infrastructure for our office. So we had an access layer, core and distribution, firewall, the one edge that was building VPN tunnels back to our backbone NDC. So this was, as I was saying, very flexible, but also quite complex, because for every layers, we had a different type of vendor, and we had OSPF, BGP, VPNs, other BGP with the providers, and so you always needed a very skilled engineers to troubleshoot any issues. So going forward, we moved what we could say our IPO time, so we started to get close to the listing on the market. And because of that, we had to start to audit all our network infrastructure, try to make it more process-oriented. And so our approach was, OK, let's simplify this stack. So we just basically built point-to-points back to our backbone NDC and eliminated the top part. So our office became very simple. We just had the access layer, and from the core, a couple of BGP sessions. This was working well. The only thing is that it wasn't very flexible, because you understand that every time we had to open a new office in a new area, we had to build a POP, and that POP connect to our backbone and so forth. So going forward, COVID ended, thanks God, and Uber went back to expanding. This time around, we couldn't use the same approach of, OK, let's just make it work. Because now we are a public listed company, we needed a scalable solution. And in the meantime, also, we did other changes in our network environment. And as you can see, now we have a SASE provider that basically is pushed out on our managed machine. So we brought security at the endpoint layer. And then, as you can see, backbone NDC is now grayed out, because we moved everything on the cloud. So SD-WAN came up, especially the Mist SD-WAN that we chose for the reasons you are going to see in a bit, became the best solution for our network, because it allowed us to scale and keep the infrastructure in standard. So now, let's look at a couple of simple cases regarding routing where SD-WAN helped us. So in this case, you can see on the left, the old stack with a point-to-point, and on the right, you can see the SD-WAN stack. Why I did this comparison is because, as I was saying, our network changed, and you can see the NDC is crossed out because we already moved to the cloud. What happened is, whoever was trying to access our internet or our internal resources that now are in the cloud, they had to go access layer, core and distribution, get to a POP, then from a POP get to an internet POP, and then from the internet POP get into the SASE POP, and then from the SASE POP, finally they had actually access to the internal resources that they needed, or they access the internal resources. you understand that all these different layers add a lot of complexity and latency on it. So with SD-WAN instead, we just basically go to the internet from the office and get into the closest SASE POP of our provider. So going forward, this is another interesting use case. Again, very simple. So we have, of course, managed machine in our offices. At a certain point, you will have to do operating system upgrades. So let's say when these operating system upgrades are launched, they're launched all at the same time. And that most likely is going to saturate your network. Even if you have two providers, like in active standby, somehow you need to move. You want to try to move the traffic of the operating system updates somewhere else. You can do it with traditional WAN, but it's very complicated and convoluted, also for being troubleshooted. Instead, with Mist SD-WAN, we just created an application. That application we bolted on an application steering policy, and then basically we kept ISP1 for running all our normal traffic and ISP2 for running just the operating system upgrades. That's very transparent to the users and actually allow us to completely solve these problems basically in 5 minutes. Going forward, let's look also at the security aspect of the things. So in this case, you can see there are two endpoints in this slide. One is the Uber corporate endpoint that, as I was saying, is managed and protected and whatnot. Then you have the guest, which, of course, being a guest, you have no information about. So when we had the backbone design, the guest traffic had to be routable as much as the Uber traffic, because it has to return to the office, of course. That means that the actual separation between the Uber laptop and the guest laptop was simply an access list, which it worked, but it can be easily fat-fingered. And in that case, you would have your guest able to talk not only with the user in the office, but also have access to the backbone. So again, how we solve it? Very simply. The Uber laptop, of course, is protected by the SASE, while the guest is going over an unroutable subnet because we have internet at the office level. But on top of that, because Mist SD-WAN provide also app categorization, we were able to basically decide what kind of traffic is actually allowed for our guest and what is not allowed. So that again solves the problem in about 5 minutes. Going forward, I'm going to talk a bit about our automation workflow and about our observability and AI. But this part is going to be just a very general idea. If you want to know more about, tomorrow we have another session longer of 75 minutes with my colleague Almas. It's TB 1812. So if you're interested in this part, I would definitely invite you over in that one as well, and you might check it out. So going back to this slide, so one of the reasons why Mist has been chosen by us is because Mist builds first the API for basically configuring the devices. And then on top of that, it builds the GUI. That way, any new feature arrives first on the API, and then it arrives on the GUI, which means the API are very robust, because that's the foundation layer of Mist. And on top of that, Mist provides also a very robust Terraform provider. What we added as Uber on top of that has been TerraGrant. TerraGrants allow us to basically remove code repetition. So our office configuration in Terraform is very minimal and very easy to read and understand. Then we basically took our Terraform bucket and add Atlantis on top. Atlantis allow us to basically commit code through the repo. So the whole system ended up in a pull request system. So that's our infrastructure as code design. So every time you need to actually change something in our infrastructure, you're going to do two different things. One, if you are a more junior engineer or operation engineer, you can just basically go on our Uber repo, edit the configuration from the GUI, and submit your pull request. Unless, if you are a more skilled engineer, most likely you're going to download the repo, do your code change using maybe Cursor or some other advanced editor, and then you're going to push that as a pull request again. And then somebody has to approve it, of course, for safety reasons. Then, going forward, let's look a bit at our observability and AI stack. So what you see here is basically, you probably have seen that Mist does provide a lot of information. There is Marvis Minis, there is webhooks, there is some telemetry. But what you can add as infrastructure engineer is the other part, because HP doesn't know how your infrastructure is or which other tools you have. So we correlate that with our SASE logs, and we also use Cape Sensor, which is another HP product, to also get a more clear picture of what is happening in our network. All of this gets pumped into our observability and then, let's say, distilled by our AI. So, and the AI helps a lot by correlating our alerts. So maybe you have a switch down with 5 access point down. That would be 6 tickets. Instead, our AI helps us to correlate all those tickets and say, hey, you have a switch down, therefore you have 6 alerts. Or it helps with the interactive data exploration. So many times it happens that you need to run a query, maybe there is a security incident, and you need to check about certain logs. And if you do it manually, it takes a lot of time. While instead, AI helps a lot with run those queries for you in a human-readable format. So let me show you how it works, actually. Sorry for the slide. I remember certain redacted file on the news, but it's a privacy thing. So on the left, you can see our engineer that is basically querying our AI, requesting how is the performance of, how is the performance of our network on the 40th floor. So how we get to this answer? So basically, what is happening is that we get from Mist all the information about where the user is sitting, because we know where they associate their MAC address on the network, on which floor. And then we correlate that with their username. And then we know, we also do an average of dwelling time, because a user most likely is going to be 6 hours at this desk and 2 hours somewhere else. So all this information allow us to know which user is which floor. Then we have web probes running from all the clients. So the numbers you see plotted on the graph are basically an average of all those web probes running from the machine of our engineers. And there are 2 lines, if you see. One is yellow, and the other is blue. The yellow line identify the probes that are actually going through our SASE provider, while the blue line identify the probes that are bypassing the SASE provider. So this way, you can also have a good idea what is failing in your network, basically, if you have performance degradation. You can see the other 2 interactions. Again, this works in a matter of 30 seconds or something. Again, the operator is asking, OK, tell me about the 40th floor or whatever other floors. And then he asks again, give me the whole performance of the whole office. This interaction, because of the database, which is where the answers are stored temporarily, doesn't need, again, to repeat, OK, give me the information of the floor X of this office, because in the interaction, those information are already saved. Then on the right, you're going to see this other Prometheus alert. So this is a message that is coming in through our observability stack. And if you see, it says firing 9 alerts. So again, this would have been 9 tickets. But because our AI correlates, this 9 tickets becomes 1. And there is also an attempt to kind of identify the problems is saying, hey, maybe you should verify your LACP member. And that might be the problem in this case, or maybe not, but we're still improving on the AI. So last, on the HP solution and what is the future. So IoT and SASE security. As I was saying, our SASE is currently running on the endpoint. But of course, our IoT cannot do that. We can't install the SASE application on the IoT. So what we're going to do, and that's more an action on us as a customer, we are going to integrate our IoT with Mist. And actually, Mist already provides that integration natively. So it's just a question of testing it and put it in production. Second things that we are interested to do is saying, hey, how we can improve our video conference experience at Uber. Many times, you probably have spotty video conference and problems of that sort, and the user doesn't know where the problem is coming. Maybe it's the network, or maybe it's on the other side, or maybe it's RAM or CPU on his machine. Whatever it is, normally a ticket gets open, and somebody needs to investigate this. What if we can use all this information and correlate them and provide the user with the immediate answer on where the problem lies? The last point is agentic AI integration. So basically, looking more far in the future, what we want to do is correlate all the information we get out of Marvis and out of all our network, and potentially also correlate with our servers, our compute, and have an idea how the network is performing in general, and if we can find patterns that are deviating from what we expect, and possibly let us know, hey, today, this thing seems different from what happened yesterday. So that regressive analysis will help us eventually to find the problems before it happens. So be very proactive on it. So last, and I would say least, is actually my 2 cents on the network panorama. So basically, as I was saying, starting from the top left, we change our architectural vision. I am a network engineer and I always look at things within my scope. And then, finally I understood when we design something nowadays, we need to also look at, beyond. We need to look at the application that we want to run. So, and that's something that really was a game changer for us, was investing on DevOps and observability. Those 2 things made our network very more reliable and resilient than what it was before, when we were approaching it just as a network problem. Another important point, in my opinion, is usability and adoption. So you need to think that even if you have a very smart engineer design something, you need to design for people that are junior or people that are actually need to use those tools. Because if you end up designing something very nice, very well thought, but it's very difficult to use, you're going to be probably the only ones using it. And then it's going to die. And the last point is, with this AI, what we noticed with the AI transformation is that many of our information that we already have are very difficult to feed into the AI as is. So whenever you write an SOP or you design a new piece that needs to pump syslog into your observability, think on a way to pass this information already formatted. Then the answer that AI will give you will be way more complete and easy to digest for the AI without hallucination and other problems of that sort, or reducing at least those kind of problems. So that was it from my end. And please, if you can give us a feedback on this session. And if you have any question, I will be on the side and happy to answer it at the best of my knowledge. Thank you.